Okay, good afternoon, class. So today we're looking at the grade 11 mathematics paper 2 of 2020. Okay, the November exam. At this point we have answered question paper 1. Okay, and we'll start now with paper 2. So in paper 2, the first question, I'm just going to close the curtains. So in question 2, normally you're given an answer book for this question paper. Okay. Very importantly is that for all your diagrams and things like that, to make notes on your diagram in your answer book. Okay. Make a habit so that the examiner, if he needs to follow through with what your reasoning is, everything is on your answer book as well. So let's go with it. We are told that the height of 11 netball players is given below. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. The first question says determine the median, the mean, the mode of these heights. So are these numbers in ascending order already? No. So we need to get it in ascending order first. So to get it in ascending order, what's the smallest value here? 155. Then 159. Then 162. Then 162. Then 166. 174. 176, 177, 183, yes, 187, yes, 991. And in your count again is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So, later on I'm sure they'd ask you to calculate the standard deviation. Can you see here? They ask you for standard deviation. So to calculate the mean is one button away from the standard deviation as well on the calculator. Not so. So what I'm going to do is, I'm going to program the calculator to do that calculation, okay? So what do is, I first press mode. I want it in stat mode. So it's number 3. 1 for variance. Okay? So to enter this in the calculator, your data don't have to be ordered here. Doesn't have to be in order. Not so. But I'm going to enter it as I got it here. So it's 155, 159. Can someone just read the values out for me? 162, yes. 162. 166. 174. 176, 177, 183, 187, 191. Okay? Thereafter we press AC, all clear. We store the data like that. Into the calculator we press shift, 1 for stat, 4 for variance. 2 is your mean and 3 is your standard deviation. So your mean is 172. Is that correct? Yes. 172. Your median is the middle number of sorted data. It's also known as quartile 2 or your 50th percentile. All means the same thing. Okay. So the median is the middle number of sorted data. There are 11 numbers. 11 divided by 2. 5.5. So it's the 6th number. So it's 1, 2, 3, 4, 5, 6. And we count from the other side. 1, 2, 3, 4, 5, 6. So your median is 174. That's all. The mode The mode is the number that occurs the most, and your mode of the data here is 162. As you can see, it's occurring more than once. Okay, any issues there? No? Next question. How many outliers are there in this data set? So what's an outlier? A value that's lying far from the data set. Not so?
Yes, sir.
So are there any outliers here? No.
So,
Because if you look at it, yes?
oh no, I was going to ask what you didn't explain, sir.
Sorry?
I was going to ask what you explain, sir.
Yeah. There's a way of calculating if there's outliers. Okay, remember we did this in stats? It is going to be quartile 1 minus 1.5 times the interquartile range. Not so? The other one is Q3 plus 1.5 times the interquartile range. Okay. So Q1, remember that is out, no? So it's 1, 2, 3, 4, 5 numbers. So that is your quartile 1 value. Okay, so it's 1, 2, 3. This is your quartile 3 value. So quartile 1 is going to be 162 minus 1.5 times 183. Remember to calculate your interquartile range? It's quartile 3 minus quartile 1. It is 162. Work that out. And quartile 3 is 183 minus 1.5 times 183 minus 162. So we get 162. This is just now to confirm there's no outliers. Okay? Into 183 minus 162. So it's 130.5. Is there any number less than 130.5? No. So there's no outliers at the bottom. Can you see that? For the top part, it's going to be 183 plus 1.5 times the interquartile range is 214.5. Is there anything above? No. So no outliers. Yeah, see that. You see, normally an outlier you can see is lying far from the data set. So if you're not sure, then it's going to be better for you to do a calculation like this. Yes, Michael?
So what if you say there's no number below 130?
130.5, there's no number below 130.5, and there's no number above 214.8 or 5.
Is it TV5 below, just below?
Just below or way below doesn't matter. Remember, the smallest value here is 155. Remember, this all part of this belongs next to you. No, that belongs there. Okay. Any other confusion there? No? And the question says calculate the standard deviation. So to calculate the standard deviation, I've already got it in the calculator, the calculations. I've entered the data, so I press shift 1 for variance. Whoops, that's data. AC. Shift 1, 4 for variance, 3 for standard deviation. That gives you 11,47. So is that your standard deviation sign? The small s in Greek is going to be 11.47. Okay? So what does standard deviation tell us? It tells us how far apart or how close the data is to each other. If the range is fairly large, the standard deviation is big. If the range is small, then the standard deviation is naturally small. Okay? Then in question for 1.4, it says calculate the percentage of players whose height falls within one standard deviation of the mean. So to calculate one standard deviation of the mean, you say mean minus the standard deviation and your mean plus the standard deviation. What I'm doing here, I'm setting up a range now for this data. Okay, so your mean was 172. So it's 172 minus 11,47. 172 plus 11,47. Work that out. Sorry? 16.
0.53.
Yeah.
And 183.
183, comma
47.
47. 74. Okay. 47. Okay, so now we count how many values lie between those values. So we're going to look at 160.5. So 160.5 is approximately here. Not so? So 162 is within. 162, 167. Let me just go change the color here. It's becoming messy. So 162 is within, not so? 162, yes. 166, 174, 176, 177, 183, and the other number is 183 comma something. So 183 is within, still inside. So how many values lie inside? So it's 1, 2, 3, 4, 5, 6, 7 values. You guys understand? So what do we then say? 7 over, you remember its percentage? It's 11 times 100. So 7 out of 11 times 100 is 63,64. So 63,64%. Okay, any confusion there? Right. Now we are on question 2. In question 2 we are to consider the frequency table below and answer the question which follows. Time taken 10 minutes to complete a maths class test. So the frequency is 1. That means to say one person took between 0 and 10 minutes. 3 people took between 10 and 20 minutes. 5 people took between 20 and 30 minutes, and so on. To complete your cumulative frequency column, we transfer 1 over. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 12 is 21. 21 plus 8 is 29. 29 plus 3 is 32. You all okay with that? You guys okay with that? This also, you can add the frequency and you can check if it's correct. That is going to give you 20, 3, 6, 7, 32. That's correct. Okay. Then it says, complete the cumulative frequency. Okay, that is the first question. Next question. Use the completed table to draw a cumulative frequency curve with the OJF graph for the given data on the axis provided. So I'm just going to get the axis that I've drawn for this quickly. In the exam you will be given this year, okay? Alright, so the points that must be plotted, and remember we take the end point of the interval and the cumulative frequency. So the points to be plotted is 10 and 1, then 20 and 4, then 30 and 9, then 40 and 21, then 50 and 29. Then 60 and 32. So the highest value in your cumulative frequency, remember, your cumulative frequency goes on your y-axis. The highest is 32. There are 10 it's a bit smaller. You can have the numbers in focus. We always try and draw the graph as big as possible, then it will be more accurate. The bigger the graph, the more accurate it is. Okay? Cumulative frequency. So the highest is going to be 32. 32 divided by 10 is 3.2. So I can make each one 3. Okay, so it's 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, which now covers 32. Not so. Then on our interval, what did our interval represent? What did it represent? Your interval, it was your time, which is 10. Okay, so here we have to 60. So it's 6, looks like it's 6 in categories. So it's going to be 10, 20, 30, 40, 50, 60. So there I got enough. Not so? So this should be 10, 20, 30, 40, 50, 60. I could have gone in 10 increments of 10 there, but then the graph will be off, on half its values on the x-axis. Okay. Right. So let's plot the points. 10 and 1. So if 3 is here, and 1 is a third away from that. Third of that, sorry. 20 and 4. So it's just above 3. 30 and 9 is on the line. 40 and 21 on the coordinate there. 50 and 29, which is under 30. And 60 and 32, which is under 33. So what I do is I connect the dots without a ruler. Must be freehand. Freehand. Okay. Then what I do is I then go to and see where this graph goes to. So it gets grounded at 0. Okay. If that value here was, for argument's sake, 5, then I would have gone and connected it there. You guys understand? But since it's 0, I'm going to connect that 0. You guys understand? Right. Now the question says, use your ogive, which is the graph we just drew, to determine the median. So what is the median, people? The middle number of sorted data. Not so. And this data is actually sorted on this ogive graph. So since there are 32 numbers, what is the half of 32? 16. So I got 15, 16 is approximately there. As you see, I'm using a ruler. Can you see? Yes, and he's hitting this on this line here. Now not everybody is going to hit on exactly midway. Not so, but it will be approximately 35. Can you see that? But you will maybe have a 34, a 33, or 36 or there. Make sense, people? So your median here is 36 or 35. Sorry. And then 2.3.2. How many learners finish the test in more than 45 minutes? Finish the test in more than 45 minutes. So 40 is here. So 50 is here, 45 is midway. Again, you see me using a ruler?
Yes, sir.
Yes, and it's just under that value there, which is approximately 26. Can you see that? You got 25, no problem. But the question again, how many learners finish the test in more than, so it's this part of the graph. Not so. So we're saying this is at 26, and this end value is at what? 30? 32. Not so. So in other words, it's going to be 32 minus 26, which is 4, 5, 6. 6 learners or students. Okay. Will you guys understand? Yes, Michael? Less than is going to be 26 people. 26 ladders of students. Okay, any confusion there? No? Right, let's look at question 3. In question 3 we are told, in the diagram, C, which is K and 5, A, negative 4 and 1, F, which is 2 and negative 5, are vertices of triangle CAF. B, which is negative 1 and negative 2, is the midpoint of AF. So that's that, the midpoint. So I can work out, look at the endpoints also given. Then we are told that CF is parallel to your y-axis. So that means to say that the x value will be the same. Not so simple, that k is equal to 2. Alright, you guys agree with that? Alright, let's look at the first question. Oh my word. Exactly what we just said now. The question says, give a reason why k is equal to 2. Why is k equal to 2? Because CF, yes, is parallel to the y-axis. It's a giveaway. I can't believe I gave you something so simple, no? This is why people don't like maths. They don't want to be so simple. And you think it must be more challenging. Alright, but we got k to be 2. Determine the gradient of AF. How do you determine the gradient, people? There we go. Gradient is y2 minus y1 over x2 minus x1. So of AF, so it's going to be 1 minus minus 5 over negative 4 minus 2. It's going to give you 6 over negative 6, which is negative 1. So the gradient of AF is going to be negative 1. Hence, determine the equation of the perpendicular bisector of AF. So a perpendicular bisector is what? A line that is perpendicular to AF. But if it's a bisector, it's cutting it in half. You see that, people? Perpendicular bisector. So if it's perpendicular, what do we know? The gradient 1 times gradient 2 is equal to negative 1. Okay? So your gradient 1 is negative 1 times gradient 2 is equal to negative 1. Divide both sides by negative, so your second gradient is 1. So y is equal to 1x plus c. To calculate c, I can only substitute a point that this graph is going through. And this graph is going through b. So you'll substitute b, which is negative 1 and negative 2. That's again an x and a 1. So negative 2 is equal to negative 1 plus c. C then works out to be negative 1. Y is equal to positive x minus 1. Okay. See me filling out all this information on this on the graph. Okay. So just at one glance, I can see what I have and what I'm shorting in. Okay. The next question says, determine the size of theta, angle theta. So if you're looking at theta, what do I need to calculate theta? I need tan of the gradient. So tan of theta is going to be the gradient of AF. But we know what the gradient of AF is. The gradient of AF is negative 1. So arctan of negative 1 is negative 45. Plus 180 gives you an answer 135. So your theta angle is 135 degrees. You guys understand? Then they want you to work out angle A. So what I do is to calculate angle A, I draw. There's many ways of doing this, okay? So what I'm going to do is I'm going to draw a line through there. Okay? which is making that angle. I'm going to extend line AF, which has an angle already of 135 degrees. Okay? So then, this, let's call this A1. Then of course A1 is going to be 45 degrees. Why? So that's angles on a straight line. So the first part of that angle A is 45 degrees. Okay? Now to calculate this angle here, that can be worked out using the gradient of AC. Does it make sense?
So can we start also?
Start over. Okay. Okay, as I said, there's many ways of doing this. Okay? What I do is I'm going to draw a line parallel to your x-axis going through angle A. Okay? Now the 3.5. Now this angle, so what I do is I extend what is this? AF. Line AF. I extend this line. Which means to say that gradient here, which is 135, is also that gradient here, 135 degrees. Not so. The same line. So the angle of inclination must be the same. But what do we notice here? It's angles on a straight line. So this part of the angle is 45 degrees. Why? The angles on the straight line adds up to 180. That's all. So I'm going to call that A1. Because A1 is going to be 45 degrees. No reason required. We're not busy with geometry. Okay? Then, to calculate this angle here, the second part of angle A, let's call that A2 for now. What do I need? I need the gradient of AC. So now we say tan, let's call it A2 for now, is equal to the gradient of AC. Did I calculate the gradient of AC already? No. So the gradient of AC is change in Y but change in X. So it's 5 minus 1 over 2 minus the X coordinate of A is negative 4. So that gives us 4 over 6, which is 2/3. Not so? So arctan of that? Sorry? 33,7 degrees. So we have enough information to calculate A. Therefore angle A is equal to 33,7 plus 45 degrees, which gives us 78,7 degrees. See this angle here. This is our angle A. Okay, we'll just take all the stuff out here. This angle here is 78.7 degrees. Okay, any confusion here, people? Okay. And the next question it is given that the length of CF is 10. So the length of CF is 10 units. Hence, determine whether CAF is an equilateral isosceles or a scaling. With triangle CAF. So when is something isosceles? We have two lengths that are equal. When is it scaling? The three lengths are different. When is it equilateral? All the sides are equal. Which means to say all the angles must be also equal. Not so? So, is this angle 60 degrees here? No. So triangle CAF will never be an equilateral triangle. So I'm not going to test for 3 sides. Okay? Right. So let's see. Which lengths you think is the same? Let's go with AF. So AF, what do? Distance formula. So x2 minus x1 squared plus y2 minus y1 squared. That will be the square root of A, which is negative 4 minus 2 squared plus 1 minus minus 5 squared. Work that out, what do you get? 6 root 2. Okay, now I thought that's going to give us 10. It would have been isosceles, now we'll stop. But AC could be equal to 6 root 2 or 10 now. So I have to do the calculation. So AC, distance formula again, I don't need to write the formula down. So for AC, it's going to be 2 minus minus 4 squared plus 5 minus 1 squared. That works out to be what? 2 root 13. So since all sides are equal, it has to be a scaling. Scaling. Make sense, people? If it was 2 lengths that were equal, it would have been an isosceles triangle. Then the next question says, if A, which is negative 4 and 1, let me move this down a bit. A, which is negative 4 and 1, C, in this order, 2 and 5, D, which is not on here, and B, which is negative 1 and negative 2. So in other words, this is normally the question that comes in here, negative 1 and negative 2. Is a parallelogram. Determine the coordinates of D. Now what happens is you could have drawn it on here. So it's going to be A, C, D, B. You could have drawn it on there. No problem. Okay? But what I do is because at this point your diagram is so overpopulated. Okay, and you can easily make mistakes. I always do it like this. Okay, there's more than one way of doing this. You can work out the midpoint of BC. Once you got the midpoint, you can work the midpoint that having that as your end point. Okay, then there's you can work out your x by saying you start here, you add that, and you subtract that. You add that to calculate your y. Or I just do it the way I do it, which is your translate or your distances. The distances will be the same. Since this is a parallelogram, that length and that length is equal, well, those lengths are equal as well. Can you see that, people? So to calculate D, if I move from A to C, am I affecting my x or my y? It's affecting your x, not so. So if I'm going from minus 4 to 2, how many units am I moving? I'm adding 6 there, not so in that direction. So if I add 6 in this direction, it's going to be negative 1 plus 6. It's going to be 5. Let's look here. I'm moving from A to B. Am I affecting my x or my y? Your y. So 1 to minus 2, how many units did I move down by? 3. So move this down by 3. So that's going to be, it was minus now. 5 minus 3 is 2. So that is your D. The D's coordinate is going to be 5 and 2. If we look here at the diagram, could 5 be there? On your x? Yes. And 2 on your y, which yes, it does make sense. Okay. You see in analytical geometry with a diagram, you could get almost 100% for your analytical geometry all the time. Okay, because it makes sense. It's on a diagram, on your Cartesian plane. Alright, let's go to question 4. In question 4 says calculate the value of k that makes the points collinear. So when are points collinear? Gradient of AB is equal to the gradient of BC. How do you work out gradient? y2 minus y1 over x2 minus x1. I could have worked out the gradient of AC if I like, if I wanted. Okay? But 2 is suffice. Instead of BC, you could have gone with AC. Okay? Instead of AB, AC. So the gradient of AB, these two, so it will be k minus 4 over negative 1 minus 3 is equal to BC. It's going to be k plus 1 minus k over negative 3 minus minus 1. So from here it's just a matter of solving for k. So it remains k minus 4 over negative 4 is equal to, that cancels, 1 over negative times negative is positive, so negative 3 plus 1 is negative 2. Cross multiplies, negative 2k plus 8. Negative 4 times 1 is negative 4. Negative 2k is equal to negative 4 minus 8, which is negative 12. K is equal to 6. Is that correct?
Yes.
Okay. Any confusion here, people? Remember, if points are collinear, gradients are equal. What does collinear mean? The points, the coordinates lies on the same line. So if the coordinates lies on the same line, then the gradient must be the same. So anywhere along that line, the gradient is that gradient. Not so. Let's go to 4.2. In 4.2, a parallelogram has the vertices M. Right, again we draw. Okay. It could be tilted and so on. Has vertices M, which is 3 and 9. A, which is negative 8 and 6. T, which is negative 1, negative 3. And H, which is 10 and 0. You could draw this in a Cartesian plane. It will look more realistic. Okay. Determine, showing all calculations, what type of special parallelogram MATH is. Okay, so you get special parallelogram. The special parallelograms are kite. No, not kite. Kite is not a parallelogram. Square, rhombus. Parallelograms from the square. So it's square, rhombus, and then square, rhombus, rectangle. Rectangle is the other. Okay. So for this to be either a square or a rectangle, the diagonals has to be equal in there. Not so. So what I'm going to do is I'm going to work out the diagonal, the distance of AH using distance formula. I've used the formula already. I don't have to rewrite it up. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. That gives us what? Then I'm going to work out MT. Let's just work this out. So it's going to be, if you calculate the x up in the exam, you press shift 9, 3, all and equal. Okay, otherwise you could have pressed mode and 1, also takes you back. So the square root of, open brackets, negative 8 minus 10 squared. Whoops, that's 2 negatives. Plus, open brackets, 6 minus 0 squared, which is 6. Gives us 6 root 10. So that's going to be 6 root 10. Okay, I'm not going to write it in, it's already messing up the diagram. Empty, same story. So it's going to be the square root of 3 minus 1 squared plus 9 minus 3 squared. What does that give us? Okay, I'll do it myself. Square root. Sound like you guys have gone home already. Hello? 4 4 root 10. Is that correct? Did I write down the points right? 9, 3, negative 1, t. So what type of quadrilateral is this? There has to be a rhombus. Why? Because the angles are not equal. There's only 3 special parallelograms you get. Square, rhombus, and a rectangle. So the least this could be is a rhombus. If they were equal, then it could either be a square or a rectangle. Then I had to check if this is 90 degrees. If that was 90 degrees and the diagonals are equal, then there has to be a square. If this is 90 degrees and the diagonals are not equal, then it's a rhombus. Not so? But because we already eliminated the fact that it's a square and we already eliminated the fact that it's a rectangle. Therefore, the only special quadrilateral it could be is a rhombus. Okay. So for 6 marks, what do they expect you to have said here? They would have to. You have to say that. Therefore, MATH is a rhombus. Why? You're firstly going to say that there are 3 special parallelograms: rhombus, kite, and square. Since the diagonals are not equal in length, therefore it has to be a rhombus. Okay. Yeah, because we have discovered this at this early point already, we have to substantiate our answer to get the full 6 marks. You guys understand? Otherwise, if we had done more calculations by proving that that is 90 degrees, then you would get now more marks as well. Okay, if you had gone that the route first. Does it make sense? Yeah, because when you do that 90 degrees, to check the gradient of MT and AH, you'll see you multiply, you get negative 1. So if that is 90, it could be a rhombus or a square. No? Rhombus or a square. Then you have to calculate the diagonals. You have to check. That's why it was 6 marks. But as I said, if you can substantiate your argument with logic, you get your marks as well. If you're going to stop right here, I don't think you're going to get the full 6 marks. Okay. People, question 5. We are given 10 sine alpha minus 3 is equal to 0, where alpha is greater than 90, which means to say it is not in the first quadrant. Alright, so we determine with the aid of a diagram. So we make sine alpha the subject of the formula. We take 3 over, then divided by 10. What does sine stand for?
So,
Yes?
I have a question. You would say alpha is greater than 180. So then can you do
If alpha is greater than 180, then the third or fourth quadrant.
so you can't go back.
Alright, so people, this tells us that sine is positive. So we sine positive. First step, second quadrant. But alpha is greater than 90. Which quadrant is that? Second, third or fourth. So it has to be in the second quadrant. Make sense? Where the 2 ticks are. Or it has to adhere to both conditions. Okay? So this should simply be in the second quadrant. What does sine stand for? Opposite over hypotenuse. It's 3, hypotenuse 10. How do we calculate the adjacent side? Pythagoras. So hypotenuse squared is equal to the sum of the other 2 sides squared. So your adjacent side works out to be 100 minus 9, or 10 squared minus 3 squared. So they give you 91. Not so? The square root thereof, don't forget, plus minus root 91. Not so? But this is on your negative part of your x-axis. So there should be negative root 90. Okay? Let's answer the question. What does alpha stand for? Opposite of adjacent. Opposite is 3. Remember, there's your angle, your alpha angle. That's your reference. Your opposite is 3 and your adjacent is negative root 91. Is it correct? Right. The next one. First apply reduction formula before we take it to the quadrant. So that will simply be cos of 180 plus. Which quadrant is that in? All stations to Claremont. 180 plus. Takes you to quadrant 3. It stands cos positive negative. Negative cos alpha. So it's negative. Cos is what? Adjacent of hypotenuse. So it's negative root 91 over 10. Which is root 91 over 10. Okay? Any confusion? No. 5.2. Different question. If cos of 15 is equal to P, write up which quadrant is 15 degrees in? Quadrant 1, 15 degrees. What does cos stand for? Adjacent of hypotenuse. My adjacent is going to be P, my hypotenuse is 1. Write the following expression in terms of P. So in other words, I must first work out my opposite side. Not so? Now you're going to work out your opposite side. Pythagoras. So hypotenuse squared is equal to the sum of your other two sides squared. Bring it over the equal sign, so it's 1 minus P squared equals your opposite side squared. The square root thereof, it's going to be 1 minus P squared. Don't forget plus minus. Okay, but is this going to be your plus or your minus 1? Why plus? The positive side of your y-axis, absolutely. Okay. So, before we go in over here, and this angle here works out to be 75 degrees. You always work out that angle. So you say 165. Which quadrant is 100? So before we take it to the diagram, we must use reduction formula first. So 165 is in which quadrant? Second quadrant. How do you get in the second quadrant? 180 minus what? 15. 180 minus 15? It's negative. Negative in the second quadrant. Negative 15. So what is cos of 15? P. So it's negative P. You would agree with that? Sometimes you do all this calculation here on the side and we don't even use it. Okay? But it's fine. I'm sure you're going to use it. Next. It's going to be sine of 105. Can I incorporate 15 in here? Yes. It can be written as sine 90 plus 15. Or I could have said sine of 180 minus 75. Same thing. Don't forget, when you're busy with your co-function, sine changes to positive. Is sine positive or negative in your second quadrant? Positive. Although it changes to cos, which is negative. But sine is positive in that quadrant. What's the sine of 15? P. So it is positive P. Next question. Sine of 15. Sine of 15. There we go. Going to use it now. Can you see that? The sine of 15. Sine is opposite over hypotenuse. So it's going to be the square root of 1 minus P squared over 1. Which is simply the square root of 1 minus P squared. Next question. 5.3. In 5.3 the question says simplify without using a calculator. So again, if it says without a calculator, what should come to mind is the special angles. Okay, the 30, 60, 90 and so on. 30, 60, 45. So sine of 210, which quadrant is 210 in? So it's 180 plus 30 times, that is negative. So add 360 to it. Remember, when you add 360 or subtract 360, that don't change the value of anything. So if I add 360, it's going to give me my acute angle of cos of 60. 130 is in which quadrant? Right? That doesn't make a special angle. So some way or other, there's an angle that's going to link to that. So it's going to be sine of 180 minus 50. Okay? Over. Now you see 320 is also not one of those Fisher numbers. However, it can link up with 50. Not so? So it's going to be cos of 270 plus 50. Can you see that? And it can't be a 360 minus. And how do I check? If I say 320 plus 50, it's going to be 370. 320 minus 50, that is 270. That's how I know I had to go with 270. And why? It's one of those lines on the cost diagram. Okay. People, 240 is in which quadrant? So it's going to be 180 minus 180. 180 plus 60. Okay, you guys agree with that? Right. So what do we get is, again we take it to the cost diagram. So 180 plus 30, second quadrant, a third quadrant, sine is negative. So it's negative sine 30. Now I know some of you can go from this straight into that, no problem. Okay, that is fine. I don't have a problem with that. The next one is cos of 60, which we are already familiar with now. 150 minus, 180 minus, that takes you to the second quadrant. You sine positive and negative. Positive, sine 50, all over. 270 plus, which quadrant is that in? 270 plus. Fourth quadrant, cos positive and negative? Positive, but changes to? Sine. Remember, for sine, for 90 and 270 changes, okay? It changes to sine of 50. Minus 180 plus, which quadrant is that in? That's in quadrant 3. Sine positive and negative? Positive. But that positive times this negative remains negative. Okay. So what happens is the tan 50 sine 50 cancels sine 50. So I need a 30 degree triangle and the 60 degree triangle. So it's 30. So sine is, 1, 2 root 3. That's your 60 degrees. So it's going to be negative times positive is positive. It's negative. So that ultimate thing is going to be negative there, ultimate sine. Sine of 30, cos of 60, minus tan of 60. So sine of 30 is a half. Cos of 60 is adjacent of hypotenuse, so half. Tan of 60, tan is opposite over adjacent. So it's root 3. So that is simply negative a quarter minus square root of 3, which can be written as 4 negative 1 minus 4 root. Is that correct? Huh? What do they have? So it could be, we'll take out negative as a common factor, so it's negative 1 plus 4 root 3. Is that what they got? The same. Alright, so for tomorrow's lesson, don't miss tomorrow's lesson, which is the last lesson. We're going to finish up the trig, graphs, and the geometry. Alright, enjoy the rest of your day, people. Good night.